In this problem, we have the function f of x is equal to sine of x plus sine of x square root of 2. And the question is this function periodic? Of course, the answer is no, and we will prove it by contradiction. So let's suppose that f is periodic with period t. So we have f of x plus t is equal to f of x for some positive number t. So already from here we have with x equals 0, we have f of x equals 0, 0 plus t is equal to f of 0. And f of 0 is equal to sine of 0 plus sine of 0 square root of 2. Sine of, and 0 times square root of 2 is just 0. So sine of 0 is 0 plus sine of 0, 0. So f of 0 is equal to 0. And f of 0 is equal to 0. F of 0 plus t is f of t. So here f of t is equal to f of 0, which is 0. So we have f of t equals 0. We know that f prime of x is equal to limit as h approaches 0 of f of x plus h minus f of x over h, and also f prime of x plus t is equal to limit as h approaches 0 of f of x plus t plus h minus f of x plus t, of course, over h. But since t is a period of f of x plus h is just f of x. So this limit is equal to limit as h approaches 0, x plus h plus t, f of x plus h plus t is f of x since t is a period. So f of x plus h since t is a period. And f of x plus t is f of x minus f of x. Of course, over h. And here you see f prime of x plus t is just f prime of x. Those two numbers are equal. So f prime of x plus t is equal to f prime of x. F prime of x plus t is equal to f prime of x. And if we differentiate another time doing the same thing, we will have f double prime of x plus t is equal to f double prime of x. And here, from here, we have f prime of x is equal to, so sine prime of x is cosine of x, plus sine of x square root of 2 prime. And here we have x square root of 2 prime is square root of 2, and sine prime is cosine, so cosine x square root of 2. Now, f double prime of x is equal to cosine prime of x is minus sine of x, and here cosine x square root of 2 prime. X square root of 2 prime is square root of 2, and square root of 2 times square root of 2 is 2, with minus, because cosine is minus, cosine prime is minus sine, so minus 2 sine x square root of 2. And now from here we have f double prime of 0 plus t with x equals 0, 0 plus t is equal to f double prime of 0. And of course this is f double prime of t. And f double prime of 0, if we plug 0 here, we will have minus sine of 0, which is just 0. And sine of 0 square root of 2 also is 0. So this number is just equal to 0. So we have f double prime of t is equal to 0. Now plug in t here. F of t is equal to 0. F of t is sine of t plus sine of t square root of 2 is equal to 0. And f double prime of t is equal to 0 here, minus sine of t minus 2 sine of t square root of 2 is equal to 0. And here, multiplying by minus 1, we will have sine of t plus 2 sine of t square root of 2 is equal to 0. Now subtracting the first equation from the second equation, sine t will just cancel and we will have 2 sine of t square root of 2 minus sine of t square root of 2, of course, equals 0 minus 0. 0. Here sine of t cancels. So here sine of 2 sine of t square root of 2 minus sine of t square root of 2 is just sine of t square root of 2 equals 0. Now multiplying the first equation by 2, we will have 2 sine of t plus 2 sine of t square root of 2 is equal to 2 times 0, which is 0. And if we subtract the second minus the first, this term will just cancel. We will have 2 sine of t minus sine of t is equal to 0. Of course, meaning that 2 sine of t minus sine of t is just sine of t. So we have sine of t is equal to 0. Sine of t is equal to 0. Now the final step of the proof. Here we have sine of t square root of 2 is equal to 0, meaning that t square root of 2 is equal to m pi, with m some integer. And also sine of t is equal to 0 means that t is equal to n pi. Of course, also with n an integer. And now dividing here, we will have, and cancelling t, we will have t square root of 2 over t is equal to m pi over n pi. Of course, here cancelling t, we will have square root of 2 is equal to, and here cancelling pi, m over n. And of course, this means that square root of 2 is a rational number, which is just a contradiction. So our assumption that f is periodic is false. Hence, our function f is not periodic. And this, of course, concludes our problem.